All right, welcome everyone to today's webinar brought to you by New Buildings Institute. We got a few folks coming in the room here still, but we're going to go ahead and get started on time. So thanks for joining us. We've got a great couple of speakers today to cover solar energy in school districts, and really, for any organization that owns solar, this is probably applicable. So hopefully we have some good information for you. We've got a quick agenda here. We'll do some welcome and introductions, a little bit of setting the stage on what we're going to talk about today, and some experiences of the audience. Then we'll jump into how to plan for 50-year solar operations. We'll discuss some power purchase agreements and best practices, and we'll have a question and answer and closing session. And I guess I should start with a little bit of admin on the webinar itself. You will be able to receive this recording and these slides after the fact. And also, please feel free to use the chat to let us know who you are, where you're calling in from. You can put questions for the speakers in there as well. We will likely address questions at the end of the webinar, but please do let us know what comes up as we go through those. So setting the stage a little bit, solar energy in schools, the idea behind today's webinar is, again, really focused on those sort of on-site operations of solar. So, carport, ground mount, roof mount, solar that is either owned by the building owner itself and managed on site, or owned through a kind of power purchase agreement. But again, the operations of the solar are actually on your facility, at your facility. And again, we'll talk about sort of some design guidelines that can facilitate that ownership, sort of that post-commissioning, or post-construction commissioning and handoff process, some data management and system monitoring thoughts and ideas, how to structure PPAs and manage those once they're up and running, and some O&M best practices. And we had another speaker that you may have noticed from the write-up online that had a bit of a personal conflict. So we won't cover as much energy and economic data management components, but we'll speak to those a little bit today, and we'll be happy to answer some questions as those come up as well. So we got a couple great speakers today. Desmond Ho is with Santa Barbara Unified School District, and Gerald Robinson is with Lawrence Berkeley National Labs. I'll let them introduce themselves a little bit more as they get into their sections. And again, just a little bit of overview of New Buildings Institute. If you're not familiar with our organization, we are a national nonprofit focused on decarbonizing the built environment. So we work across the commercial building sector. I personally work with the school sector as well, and we're happy to chat with you all today. So we're going to dive into a little bit of getting some information from you all. This is our unofficial mascot for polling software, the polling possum. We are using Mentimeter today, so you can join at menti.com. Use the code 45124930 that you see on the screen there, or you can scan this QR code. We'll have this up on the subsequent slides as well. I did want to frame the first question a little bit. It's going to be related to whether or not folks online are owners of solar. And again, just to sort of clarify, when we're speaking about solar ownership, we're really focusing on the sort of ownership model on the left of your screen there, where it's owned by your organization and operated on site, or a third party owns it, through a power purchase agreement, and it's operated on site. Other models, such as community solar or power purchase agreements, where the solar is located somewhere else, or you're simply purchasing solar through your utility provider, are not as much covered today, because again, this is focused on the sort of operational components. So we can jump into the first Menti here. And we would be interested to know, for the folks in the room today, what is your sort of status of solar ownership? Does your organization own and operate solar? Do you have PPAs in place? Maybe you have both. Maybe you're purchasing off-site solar renewable from a utility. Maybe you're not a building owner. Please go ahead and throw in some responses. We'll give that a few minutes. And I'm realizing I didn't introduce myself. So I'm Shannon Oliver. I'm Senior Project Manager at New Buildings Institute. Happy to host this webinar today. Yes, thank you for throwing the code in the chat there. Again, it's menti.com. Code is 45124930. Looks like we've got a couple of folks that have some on-site, a couple of folks that do not, and many folks who are not building owners. We'll give it another second to get some responses here. For those of you that are not building owners, I think hopefully maybe you work in this space or are interested in supporting some building owners to have solar on site, and so ideally these will be relevant topics for you all. Looks like we do have some solar ownership as well, which is great. I'll give this just one more second, and we'll move on to our next question. Okay, you all can keep answering that in the background. We'll have some of that data to look at after the webinar here. Second question for you this morning is related to these considerations we're going to be talking about today. All of the sort of the considerations listed on screen here in black really are front end, right? These are items to consider during planning. How is the solar designed? What are the structural considerations? Is it are you going to own it? Is it going to be a power purchase agreement? Where is it sited? What are the utility rates? These are all things that you should consider during planning. And there's a lot of information in webinars and recommendations around how to set yourself up to have solar. But kind of what happens, following construction? What happens once you are sort of up and running and operating the solar? And so we want to know folks' experience with that. And kind of the question is, what was one thing you wish you knew more about prior to becoming a solar owner? Kind of what's been the steepest learning curve? I suppose for folks that are not a building owner, this may not be relevant, but go ahead and rank which things really jumped out at you that you struggled with. We'll give folks a couple seconds to respond. And again, the Minty code is 45124930. Looks like we've got some data coming in here. And if you do answer number 6 other, please feel free to enter it into the chat. There may be things that we didn't think of in our planning for this webinar. But looks like currently operations and maintenance is jumping out up there. And so we've got looks like someone threw in the chat, attachment methods or ballast systems. I believe Gerald will be speaking to that today. So, that's certainly, as you are considering this solar ownership, that's a really key component of the design for sure, and then how you're going to maintain those systems. Looks like O&M is a really big topic today, which is great. Both Gerald and Desmond will be speaking to that. Data insights and dashboards as well, right? How do you manage this data? Is it a third-party system? Is there management you can do in-house? Well, this is great. This is great information. Well, we will, again, let that keep running in the background, and I'll go ahead and hand it off to Gerald, and just let me know when you'd like to advance slides, Gerald.
Hey, thank you. Thank you, Shannon. Gerald Robinson from Lawrence Berkeley Labs. I support 3 different public sector programs. So I work on federal on-site solar projects. I support the NBI and schools, and I support another program that does state and local. So I have a lot of public sector background experience. I have a research hat, and I'm very involved with the reliability community. And I work on severe weather and solar, particularly wind and structural challenges. And I do a lot of spec writing. So got a lot of background in quality management. So what I want to talk about today is I want to talk about what is the fundamentals of quality, safety, and reliability, success with elevated PV structures, success with low sloped roofs. And then I really want to spend most of the time on O&M topics. So why O&M, and then elements of an O&M plan, and then budgeting and contracting O&M services. Next slide. So before I begin, because I will be highlighting some failures, is I want to make sure that we keep things in perspective, and that is solar is a very highly reliable technology. This is a big data set, 100,000 plus. They actually have just added to this data set systems, and the majority of the systems are operating within 80 to 90% of their expected. So the one topic where performance does fall short is there's a hardware issue. And it usually arises in the first few years. So there's a lesson in that for us all here. So next slide. Another point of context I wanted to lay some groundwork on is that the state of the industry is one in which it's really a maturing industry, which seems probably like an odd statement because we have so much solar going in. But the important takeaway here is that in a matured industry, we rely a lot on codes and standards. When an industry is maturing, minimum good practices are not codified, they're not written down, and they're a little bleak. And that's the kind of information we hope to bring to you today. And we really call that sort of best practices. And it's knowledge that's sort of in ownership of those that own and maintain systems and build systems. So that's the sort of spirit to keep in mind. There's a lot of esoteric knowledge out there. Next slide, please. And the just an overall for those that I'm going to touch upon some topics for those that are planning to do systems in the future, but some of this also relates to those that are managing existing systems. But one of the things that I've seen in supporting agencies that do projects is that there's a process that matters almost or more so than really having good, let's say, technical specifications, right? So what I've seen is that there needs to be this sort of chain where technical requirements flow through to the procurement documents, which then in turn flow through to a contract with the awardee. And then the agency, either directly or through its consultants, need to be able to perform a submittal review. That's of the design documents. You need to have some construction oversight. You need to follow good commissioning practices, which is represented by an IEC standard there. And then obviously O&M. And these taken together will result in what Shannon referred to as a 50-year system life. But oftentimes something will fall amiss in this process. But next slide. So I want to begin by talking about solar modules. I am very involved with the reliability community, and one of the problems right now is solar failures are on the rise. A lot of vendors or contractors or people shop based on what we call tier one, and that's an investment indicator. And really, the modules need to be qualified through a very aggressive accelerated testing regime represented by PV Evolutionary Labs and RETC, which, by the way, make their data available. And agencies should not rely on simple IEC and UL standards because they are not predictive of the future. So should your module fail, and some may have failed modules who are on this call, you have a challenge ahead of you. So very important that you end up with a highly vetted, qualified module on your project. So it's job number one. So next. And then another area that we're seeing a lot of problems with is a thing we call critical structural connections. And that's what that essentially means is the module mounting and rack assemblies. Here's an example of a point I made earlier where, codes and standards are really lagging behind actual field experience. And most of the joints shown here are not well represented yet in solar specific codes. So they tend to be, they fall outside of good practice, and there's been a lot of failures here. So we're promoting a better set of practices here. And next slide. And wire management, here's another area. This is the single biggest cause of underperformance is wire management. And in worst cases, sources of electrical fault and sometimes fire. Um, there's large data sets of folks that go out and do inspections of systems, and wire management is the biggest challenge. So not using plastic wire ties and dealing with quick connects, which is shown here in the middle picture, and I'll talk a little bit more about that later, are two major topics right now. Next slide. And one thing to keep in mind is those that have power purchase agreements, which I'm a big fan of, versus owning, you still have to worry about safety, right? So if it's on a school site, you have to worry about structural integrity and then electrical shorting. And that is acutely true of roofs and carports. And then there are some schools that rely on these systems to be there when there's an outage or be part of emergency response. And so you do have a technical stake in a PPA project. Next slide. So this is an example of a carport exposed to Santa Ana winds in Southern Cal, which I believe were 25, 30 mile an hour winds. And this array here was taken apart. This was the state architect approved design. We're seeing a fair number of these. So right next door to this parking lot was a playground. So just getting back to the safety issue is pretty acute. And I'll talk a little more about the PV elevated structures are the least represented in code right now, structural code that is. So they're of a particular challenge. Next slide, please. So the good news about those that are planning parking canopies, which are widely popular in general, unless you have some visibility issues with neighbors or something, is they are fundamentally enabling structures. So you can build, future-proof them and add extra wiring and conduit for EV adoption that might come later. And they do a number of good things for the site. They reduce heat island effects, provide shade for vehicles, and reduce the need for a lot of air conditioning when people get in their cars. I mean, they protect fleet vehicles and school equipment. They can be used above buses. They're a wonderful application. So highly encouraging of those. So next slide, please. And then another area is that carports are ideal for resilience in terms of emergency response. So they provide space, lidded space, and room for batteries, and you can do staging, mobilizing, hoteling. You can do a bunch of functions underneath carports, and they're really ideal. And there's other ways of energizing carports without a full microgrid. Should anyone have existing systems, I'd love to talk to them about that. So anyways, a good asset for a site. So next slide, please. And then getting back to the structural topic, there's a committee, Solar Structures Committee in the Society of Structural Engineering, American Society of Civil Engineers, excuse me, has a solar committee, and they're recommending a certain approach to carports. And I've just provided a slide here. And anyone who wants some detail here, I can go into that. They're discouraging the use of what we call monoslope methods. So, but anyone want more information there, I'm happy to provide it. Next slide. And carports in winter are unique. So if there's any folks that are in areas that receive precipitation that's frozen, you'll need to design these systems to prevent black ice from underneath. And that is the number one source of lawsuits for those that own carports on properties. And so there's a big lessons learned here. I won't go into every detail here, but there's a lot of things you must consider. And the Y design, by the way, has become popular because it prevents ice and snowfall on pedestrians below. But next slide. And on roofs, I wanted to touch a couple of important points on roofs. We see low tilt ballasted, low tilt fully anchored, and low tilt hybrid. We're pushing folks to really do low tilt hybrid, to never do 100% ballasted systems. Those are challenging and unsafe. And then the two systems on the right, what we call flush mount, and east-west systems, are very problematic from a maintenance perspective, and present some other problems with maintaining the underlying roof. So we're discouraging those systems. Should you have them existing, don't despair. You just have to take some extra steps for maintenance. But next slide. So encouraging folks to install what we call roof-friendly systems. So I worked for the company that produced this product some years ago now. It was award-winning, and wow, do we learn a lot from that. That is not a roof-friendly system shown there. You cannot maintain the underlying roof, you cannot locate leaks, and you also cannot maintain the solar system itself. So those that own these styles of systems are, I'm sure some are on this call, or will attest to some extra complications. And anyone that has one of these systems that's struggling with it, I'm happy to talk to you about it and help you through that struggle. So next slide, please. And then, just quickly, for those that are planning a new system, there's what we call roof friendly. And that's basically some core principles. Can you maintain the solar underneath? Can you perform visual inspections? Can you physically access and do repairs? Can you remove leafy debris? And do you minimize negative interactions with birds and rodents? And then we're highly encouraging folks to relax a little bit about array spacing, because you need to be able to get between the rows to maintain the roof and the solar. And it does not make as much of a difference as you think in the power output of the roof. So we're encouraging designs that are relaxed and spaced amply. So next slide. And just a couple examples of the types of things that you will need to do to maintain your rooftop solar. One of the things I want to point out for those that are in snow country is you need to demarcate the boundaries of that should you get a deep snow and you need to remove some snow from the roof. And there's some really interesting, easy ways to do that. But I don't want to, there's a bunch of O&M lessons here, but let's move on to the next slide and we'll come back to this. And the other thing that I want to mention is that the solar itself always needs maintenance. Solar is not maintenance free. I'm sure everyone on this call appreciates that. So that's the other reason to leave rows between your solar array. So you need to be able to access every part of it, and you will need to do work, replace modules, connectors, tighten things, on and on it goes. So next slide, please. And then there's ways to mitigate negative interactions with wildlife. Here's a couple examples. One neat trick I've seen is suspending monofilament fishing wire above roof arrays will keep birds away and not deter output. There's some other tricks too, but here's a few examples of products on the market that work well. So next slide. And then another structural topic, this related to roofs. This is why we discourage 100% ballasted systems, even though the industry is really pushing them. The industry's response in a windy climate is always, well, we'll add more ballast. But in reality, you need to have mechanical attachments to the roof underneath. And this is a design guidance for structural engineers that show how to place those anchor points to minimize the number of anchor points, but how to place anchor points strategically to keep that array in place. Next slide. And another structural topic for roofs is a thing we call billowing. So mechanically fastened roof membranes suffer from a phenomena called billowing. So when the air pressure exterior of the building is lower than that inside the building, the roof membrane will poof up and billow. And during a thunderstorm, when there's rapid changes in pressure, it will displace and dump the ray, anything else on top, as shown on the right. That was an incident at a General Service Administration building during a thunderstorm. So this is happening more than you suspect. So ideally, roofs should be fully adhered. Should you have a mechanically attached roof, you will need to add mechanical attachment points. And again, if that isn't a challenge that someone has, I can provide more information on that. That phenomena is well detailed and there's ways to mitigate it. So next slide, please. And just this is getting back to this ballasted topic, just talking about, when would a 100% ballasted approach be appropriate? And those that have dealt with failures would largely say probably never. You should never ever do a 100% ballasted system. They always need to be mechanically attached, at least in strategic points, as dictated by structural guidance. So don't want to belabor this too much, but let's move on to the next slide. And electrical fires are, I don't want to overemphasize this, but they do happen. And this relates back to the first slide where I showed the east-west and the array that covers the entire roof. Electrical shorts that are hidden behind something without air will pick up heat and accelerate and then make it impossible for fires to access that flame. It's another reason to have row spacing that is generous and have good wire practice. So very, very important. So next slide. And let's move on to O&M quick. I don't think most people on this call really need a lesson of why O&M is important, but just quickly, it increases the effectiveness, the impacts of money spent, increases overall performance, reduced downtime, increases the lifespan of the system. That's not well appreciated. Keeps equipment within warranty compliance, reduces safety risks, and the systems just look better. Next slide, please. And then, what happens if you don't care about maintenance? Here's some examples. And I deal with these almost on a daily basis. I help folks go through having to catch up on deferred maintenance and rewire, repower. And these are classic deferred maintenance challenges that we see in solar. Next slide, please. And so really on a high level decisions that need to be made, do you have a formal O&M program? Those are those that own their own systems. And so you have to ask yourself, are you going to self-perform, which I find in the public sector is not usually very practical because people are very understaffed, or hire an O&M provider, or kind of do a combination of both. Some people like to at least clean their own systems and then hire out the more complex work to a contractor. So next slide, please. And then the elements of an O&M plan, really, it's not too complex, but you have initial inspection, and most public sector folks are at a state and time where they're, we all have these assets now, we've installed them. Now we're facing O&M, right? This is the big topic right now. And so what usually is occurring is a lot of these systems will have deferred maintenance backlogs because a program's not in place. And this, by the way, is across the board. I see this everywhere. So, you now need to do an initial inspection of what corrective actions need to be made. It's kind of a you're baselining your system, like where are you at today and what do you need to do to move your system forward to a state where it's normally operating. So you need to plan for that. You will need to implement that. And then you're going to need to move into recurring electrical inspections, which is critical. You're going to need to adopt module cleaning. Some people will argue that you don't need module cleaning. That is generally not the case for most areas. And then do some level of fastener inspection and tightening on a routine basis. And then you have your site to maintain. And then the big topic right now is metering, reporting, and just some simple alarming. We don't even know often if our systems are really on or off. That's how much we need to focus on this. And cybersecurity has complicated our life in the metering piece, but this is a big topic, the metering, reporting, and alarming. So next one. So we have some resources that were developed for the federal government, but are very generally applicable. And so I provided a link here to one of those resources. It's a template, and you can just cut and paste from it to create a scope. And it has some general terms like site access that you might find useful in putting together a contract. And this is a resource that's on the General Service Administration site, and these are two ways you can access that resource. And in the government world, we call it a PWS, that's called Performance Work Statement, but it's really just a scope of work document that you can grab stuff from. It's been thought through over and over again, and it's a very, very well composed tool. So I highly encourage folks to check it out. Next slide, please. And some key budgeting topics is that a lot of public sector folks really have a color of money challenge. And basically what that means is that you want to spend maintenance dollars to maintain your solar system, but you're benefiting a utility budget. Those are often two separate budgets. So you're going to need to go back and do some budgeting work and move money around so that you have adequate maintenance funds. And the other thing to remember is solar PV O&M is cost effective. You can overspend certainly, but the performance gained is far greater than the cost to achieve it. So that's very, very important. How much will it cost? So, corrective actions plus the routine and the unforeseen things. We have a cost calculator. It's not posted online. It is available, and I can send it to you. It's maintained by the National Renewable Energy Lab, and it should have updated labor rates. And it's a very, very, very useful tool. So anyone should need that. I'm happy to email that out. And then how to pay for O&M is another big topic. There is a performance-based approach where you pay your O&M provider for every kilowatt hour they generate, right? So it usually comes out to less than a penny. And that is something that folks should consider should money be difficult to budget for. So anyone interested in that, I'm happy to talk a little bit further about that one too. But that's a neat approach, and it's effective. So next slide, please. Should you have an existing system with recurring problems, because most of us do, we're now trying to struggle to manage this asset. There is a resource. It was largely the original inspiration was around weather vulnerabilities. However, it has a lot of other just general good stuff in it. And here's a link to that. And it goes through wire structure, goes through the bird and rodent management, all kinds of great stuff. And it's a compilation from best practices all over the industry from a lot of system owners weighed in on that document. So this is a really good resource for you. So next slide. And then here's some more resources. These are federal resources that I think are very, very ubiquitous, regardless of who you are, whether it's a public sector or commercial. These are great resources that I hope you will avail yourself of. So next slide. And then here's some resources for severe weather because this is becoming a greater topic for all of us, right? Um, Hail and wind are the two big causes of insurance claims right now. Some of us had floods for ground systems. Some of us have corrosion. Some of us had big snow loads. So we have some great resources. These are very well done. Um, I know some of the authors, they really went to great care to put these things together. Hope you can utilize those. So next slide. And then should you have any questions, feel free to reach out to me. I'll send you any follow-on resources and please reach out to Shannon. But we're glad to support your efforts in any manner you need them.
Awesome. Thanks, Gerald. We'll be hopping over to Desmond now. Desmond, just let me know as you'd like your slides advanced.
Right. Hello, everyone. My name is Desmond Ho, and I am the Operations and Sustainability Coordinator as well as a project manager for Santa Barbara Unified School District. So thank you for having me here today to speak to you about our solar and microgrid project. In my presentation, oh, sorry, next slide. So in my presentation today, I'm going to be going over the inspiration behind this project, how it's designed, the use of a power purchase agreement, operations and maintenance best practices, and how we see the data, as well as things that we're still trying to get our contractor to provide for us. Next slide, please. So just a quick background on Santa Barbara Unified. We're a school district with 12 elementary schools, 4 junior high schools, 3 traditional high schools, and 2 alternative high schools. So we service approximately 13,000 students with about 57.7% of our students on free and reduced price meals, and we have about 1,600 staff. Next slide, please. So those of you that are unfamiliar with Santa Barbara or California in general, we are 2 counties west from Los Angeles, and we actually rely on our neighboring counties to supply our electricity. So our county is a little bit different than most places in California in that we have a mountain range that runs east-west, and that range actually splits our county in half. One utility provider services the northern portion of the county, and then another utility provider services the south portion. And our school district is in the southern portion of the county, and we service students from 2 cities as well as the unincorporated areas in between. Next slide, please. So our grid is vulnerable. If you take a look at this image here, the yellow lines indicate power lines that come from this county in the south. And there's also this main purple line, which is our main power that runs through a wilderness of Los Padres National Forest and has very limited access in that east-west mountain range that I spoke about just a slide prior. So with the increasing frequency of wildfires and also flooding events, our utility provider thinks that it's anywhere between 1 to 3 months before they can repair any sort of damages if these power lines were to be taken down. We had a fire in 2017, the Thomas Fire, which at the time was the largest fire the state had seen. And this fire actually got pretty close to taking out some of these power lines. So it's not a matter of if something like this can happen, but when. Next slide, please. So just to give you a little visualization of what fire risk to us in Santa Barbara is like, the yellow area on the bottom is the developed area of Santa Barbara as well as city of Goleta. So the green splotch is fire coverage from 1980. So these are the areas that burned in 1980. If you go ahead and simulate, yellow is going to be the 1990s. And then orange, these are 2000s. The red is the 2010s. And then finally, the purple 2020s. So as you can see, we have some pretty significant fire risks that really impact our area here. Next slide, please. So with regards to community resiliency, our school sites serve as emergency shelters during natural disasters. With our solar and battery microgrids, we're actually powering the largest kitchens, gyms, and multi-purpose rooms. So we have the ability to feed and shelter the community when there is a need. This was the case in that fire in 2017 and also the subsequent mudslide in 2018 and also in 2023. So this picture that you're seeing right here is our only freeway going southbound, and it was flooded in 2018 and 2023. Unfortunately, when this freeway shuts down, it takes about 6 hours to go to Los Angeles, where we get most of our supplies. So we believe that these microgrids that we have installed at our school sites is going to better position our school district to help our students, their families, and the community with the increasing frequency of natural disasters from climate change. Next slide, please. So from the close call in 2017 and also a better understanding of our vulnerability, we decided in 2019 to begin exploring the installation of solar and microgrids. Um, Basically, the microgrid is a battery storage system that has a smart controller attached to it. And with the completion of this, we installed 14 arrays, with six of these having microgrids. So instead of doing rooftop, we targeted actually parking lots where it's feasible for high schools and junior high schools. And then on the play fields for the elementary schools, because the parking lots were too small and the students actually prefer the shade because we are in a sunny Southern California. Rooftop was also not considered because of the fact that our roofs are not in the best condition and they would require re-roofing or just a redesign of the roof in order to sustain these arrays. This project is basically going to cover at least about 70% of Santa Barbara Unified's overall electricity use, and it's going to offset about 93% of our greenhouse gas emissions from utility electricity use. Next slide, please. So the way that our microgrids are set up, the smart controllers look at available battery power, power demands, and then basically switches things on and off based on the predetermined tiers. Our most critical tiers are going to be our critical loads, like our walk-in refrigerators and freezers, and also our emergency facilities and communication equipment. So with that, the tier one loads, assuming that it's sunny outside, is going to have 100% uptime. Tier two loads are going to be like lighting and HVAC equipment in multi-purpose rooms and gyms, as well as the site's communication equipment. And we're expecting that to be about 80% resilient, like or uptime. And then finally, for the remainder of the school, it's going to be a less than 25%. The great thing is this is a seamless transition. So when power is lost, the students actually have no idea that that's happened. So life goes on, especially during the daytime when it's sunny out. Next slide, please. So for us, we decided to go with a power purchase agreement or PPA. Our district did not have the capital funds to pay for the installation of such a project. And we actually negotiated a flat, non-escalating rate for 28 years. I think this is really critical, especially in helping our folks, our fiscal folks project out energy costs. Having that flat rate is really, really nice because our use is pretty steady. So it helps them easily project out what the energy cost is going to be from year to year. We also knew that there are going to be construction change orders, consulting fees, legal fees. So we actually negotiated with our provider where we exchanged a higher rate and they gave us a $1.2 million contingency fund so that we could use this to help pay for any sort of change orders and et cetera. Originally, when this was negotiated in 2020, we projected a savings of about $7.7 million. It's now been updated to $14 million over 28 years because of the fact that utility rates increased substantially in the last 3 years. Next slide, please. So a lot of you mentioned earlier, how do you verify savings? This is also a conundrum that we're working with. It is extremely tedious if you're not using some sort of expensive third-party platform. So for us, one example here is a junior high school. This is La Colina Junior High School, and we have solar billing of February in 2025 on the left underneath, and then utility from 2023 in the same period in February on the right side. Before solar, we were paying 18.7 cents per kilowatt for transmission, and then another 8.5 cents for generation, totaling 27.2 cents per kilowatt. And we're paying about $4,000 for this bill. But then if you look at the solar bill on the left, it's like almost $3,700, which is less, but seems insignificant at first. So the total solar generated does not equal the total being used on the site. So on the right there, we're seeing that the typical usage is about 14,000 kW, and then we have excess generation here at 21,000 kW, and that excess generated is still going to be billed. However, we're going to get a credit for that for later on when we're using more than what is being generated. So realistically, we're only paying about $2,400 if we're using 14,000 kW as our baseline. So this is basically one site for 1 month. So if you extrapolate out to however many sites you're going to have, I think I would really recommend using a third-party software or company to help you verify savings. Um, I would tend to shy away from PPA providers because they're going to be incentivized to kind of bend the numbers or bend the weather data, especially if you have some type of performance guarantee. Next slide, please. So now that we've had these systems operating for a few years, we've learned a few best practices and insights on what's important to have if you're going to get into a PPA. The operations and maintenance, the O&M package that a lot of PPA providers give are very valuable. These systems are very complex, and we've already had a few inverters fail, as well as a few breakers, components of breakers fail in the first year or two. So these normally would have been costing us a lot of money to hire external contractors to come and repair or replace. And the other thing is having a performance guarantee with your PPA is a very good way to ensure that you're going to get the power that you're promised. But a byproduct of that is that our PPA providers, O&M team, they have been very proactive with coming out every 6 months to clean the panels. And also they reach out very quickly to let us know when they see something is offline, and then they also go and fix it pretty quickly. So a little quirk that I've learned living somewhere coastal where there's a lot of constant condensation, dew, or if you're living somewhere like in Seattle where it rains frequently, um, the panels, even if they're flush against each other in the carport style, water obviously has to drip down somewhere. So we're finding that the areas where they drip down, they're slowly starting to form trenches in whatever medium that they're dripping down against, whether it is dirt or asphalt. So I really recommend that these lots, wherever it is that you're installing these, be inspected by your grounds crew to either fill with additional dirt if it's a dirt lot, or reslurry your parking lots more frequently. And this is something that we didn't account for, and something that I would never even see unless I was out in the lots during breaks where you can basically see straight down the line. And I'm seeing these little tiny trenches starting to form. So something to think about, either a gutter system or a way to manage the drainage would help ensure that the areas that you're working with will have a little bit less maintenance. Next slide, please. So microgrids are still a newer technology, and we have been fortunate to test and find out some weak points associated with these systems. So over the last 2 months, we unfortunately had 3 power outages here that lasted more than 1 hour. The first outage actually exposed a weakness in our system in that one specific phase of power was cut. I think a squirrel or something chewed a wire, and that phase just happens to be the phase that powers the microgrid controller that turns on the battery. So since that was cut, the controller couldn't tell the batteries to turn on. So when the site lost power, the batteries couldn't turn on to basically back up the power on the site. So the solution to this was to install a small UPS battery to ensure that the microgrid controller will always have power. So essentially a tiny battery to power a big battery. And then about a month later, we had another outage that actually had wild voltage fluctuations that actually destroyed some of our equipment at our district office that didn't have sufficient surge protection. And then also the fuse on the battery module blew in order to protect the batteries from this exact scenario. So since the fuse was cut, the batteries could not be turned on because once again, the controller was not getting battery or power. So right now I'm still working with our PPA provider to figure out how to solve this issue. So you might be wondering why we didn't test for all of these things ahead of time. So these are things that couldn't really be accounted for without testing because the grid was still live when we're doing the testing. So I really don't recommend that you cause any sort of power outages in order to test your system. So the only way you're going to be really able to see some of these weaknesses when power outages actually occur. We're fortunate that these were just minor outages that exposed the weaknesses, so we can fix a lot of these before the major outage occurs. So know that when you install set systems like this, you're going to have teething pain. People are going to be upset. They're like, well, these are brand new batteries. Why aren't they working? So manage people's expectation. Like things are going to go not poorly, but things aren't going to work exactly as you intend for a little bit. But once it's all set, everything's good. You should be good to go for a while. Next slide, please. So now that we've talked a little bit about our systems, best practices, lessons learned so far, let's dive into a little bit of data. So NG, which is our power purchase agreement provider, provided us with a platform called Utility Vision. So this gives me data range, or data that range from things as grand as annual data down to as granular as 15-minute intervals at all of our sites. So this is 2 days of data from Santa Barbara High School from when the system was first commissioned. So you'll see 3 lines here. The purple or maroon line indicates solar output. The orange line is site usage from the grid, and then the blue is battery charge and discharge. Discharge is going to be the area above the zero, and charge is the area below the zero axis. So the data is showing that we were typically discharging batteries from 5 to 9 a.m., and then the batteries get charged from about 10 to 3 p.m., and then they discharge again starting around 7 p.m. Having a platform like this was great because we were seeing that the peak shaving functionality of the system was not actually set correctly. We want to see the batteries discharge from 4 to 9 p.m. because for us, that was the highest utility rate, and that's when we want the batteries to discharge. However, we wouldn't have known about this unless there was a platform like this for someone like me to be able to verify that. So ensure that whatever PPA provider, whatever you're getting yourself into, that you have a good data platform that you can see what's going on. Next slide, please. So that utility vision platform is good, but that's not the public facing side because most of the public is not going to know what they're looking at. So we asked NG for also a public facing site, and the picture on the left is the dashboard that they provided us. Unfortunately, this is super cluttered and kind of hard to tell what's going on as well. So I'm asking them to kind of fix this a little bit. And also integration onto third-party web platforms is something that you want to make sure that your website, if you're thinking about incorporating this onto your school district website, so that's going to work with them. Because right now we're having issues incorporating this on our website. So it's going to be a bit of a headache getting 2 different platforms to work with another. So one of the missing pieces that I would recommend any platform to have is, first of all, I have no idea to whether a school site's power is out. I routinely get calls from our COO asking, "Hey, I think a school's lost power. Can you check and see?" And I have no ability to ascertain that. So I've asked our provider to give us some type of indicator or something that announces, "Hey, this school site's power is out." That utility vision platform that I spoke about earlier, that data is delayed by about 30 minutes. So it's not very helpful um, to have that delay. And then the other part is if you're going to have a battery storage system, ask your provider to give you some type of data on state of charge because you're going to be asked that question, hey, how long are the batteries going to last? Sure, I got 450 kWs of battery, but unless I know what the school is using on a regular basis and how quickly or slowly that is draining the batteries, you're not going to be able to extrapolate how long the batteries are going to be able to last, and also based on weather conditions. So getting some sort of battery projection is going to be very helpful because you're going to be asked that question, hey, how long will these batteries last? Lastly, if your school district is interested in looking at its greenhouse gas emission reductions, getting a platform that kind of spells out how they calculate those GHG reductions is very helpful. The platform that the NG provided us just says that you reduce X amount of metric tons of the GHG, but there's no calculation as to how this is calculated or anything like that. So if that's important for you and your school district, make sure that you talk to your PPA provider about what that is going to look like. Next slide, please. Thank you, everyone, for your time. And then I'm going to hand this back over to Shannon.
Awesome. Thanks, Desmond. Thanks, Gerald. We've got some good questions coming in the chat here as well. So we'll jump into those. We did have one last little Menti we'd love for you all to participate in. It looks like some folks have maybe you started putting some stuff in there. Feel free to work on that in the background. Looks like several of the questions in the chat did get answered. Gerald responded to Scott regarding the ballasted systems, as well as Robin. Please let us know, yes, if we can help you out there. I have a question here. How common is it for manufacturers to offer O&M plans, and are they worth it? So Gerald or Desmond, feel free to chime in on that one.
The manufacturers will offer warranties. Those are product specific. The O&M comes from O&M providers, which could be separate companies, or sometimes installers also have divisions that are O&M service providers. So that's where you get your services there from. I don't know, Desmond, is that your experience?
Yeah, yeah, manufacturers don't give you any sort of O&M plans. Those are going to be your contractors. The larger contractors will have their own O&M department in-house. When we went out for an RFP for our project, that was a consideration whether they're going to do it in-house or they're going to contract it out. We wanted something in-house because it's easier for communication and they just work a little bit better in our experience.
Awesome. There was a couple questions for you, Desmond, about like total solar, megawatts or kilowatts and batteries. So if you want and are willing to share that, I'd say go ahead and drop it in the chat so folks can see that.
Sure.
We got a question. Can you provide more info on how often we should consider module cleaning? I don't know, Gerald, if you have best practices there.
Yeah, module cleaning is very site specific. So some people will add a dirt sensor, so that is triggered by need. Other people will just go ahead and schedule cleaning on the calendar. They'll say, okay, every, at the beginning of the high performance season, so they might say every beginning of May, they do it regardless. So there's a couple different approaches. If you live in a urban environment with a lot of gummy particulates, you may need, or you're in an agricultural region with a lot of dust, you will probably need to do more cleaning. But so again, it really depends.
Excellent. Thanks.
We're doing it every 6 months, just because a lot of our schools are kind of like near like large roadways.
Yeah. Yeah, so probably the take-home message is having eyes on them occasionally and sort of cleaning, more often as needed, would maybe be the simplest answer, I suppose. Desmond, there's a question. It said, did you share funding with counties, cities for infrastructure costs as you are supplying emergency shelter and power? And does your model, your costing model for the microgrids include O&M costs?
Sure, funding. I mean,
So
we just provide our facilities to the counties and cities as just like good faith, I guess. Like we don't charge them anything. If there's an emergency, we're gonna open up our facilities because that's just what we do. And then O&M costs, that was just baked into our PPA, so it was just made simple. We didn't have to go out and have a separate line item for the O&M part.
Yeah, definitely. And another one for you, Desmond, the fire map, how'd you get that resource?
That I believe it's a CAL FIRE provided map. So I just took each decade data and then overlaid them on top of each other. So I just slowly created that from a publicly available source. I believe that's available for anybody in California to see your fire areas from 1950s onwards. Yeah, I didn't include that data. I just wanted to go from 80s, so not take up too much time.
Yeah, that makes sense. Let's see, we only have a couple minutes left, so I do want to address a couple of these. Maybe Gerald, Scott did sort of further ask about ballasted versus fixed roofs in the chat regarding roof penetrations. If you want to maybe respond in the chat there.
Did you want me to respond in the chat?
Oh, yeah, actually, sure.
Okay.
Why not? We can wrap up with that one.
Yeah, no, but ballasted is a big topic. Industry is really pushing 100% ballasted. You're in a school district. It's your primary concern should be safety. I've inspected systems all over the country that have come off roofs. I've never seen anyone hurt. I've certainly seen automobiles damaged. Winds that come up over a roof, over a parapet and around penthouses are powerful, and they will drag arrays up and over and down onto the ground. So it's a very, very big topic. Roof penetrations are not a big deal. They have to be done by a qualified roofer, but you need mechanical attachments, and there's two very good structural guidance pieces that you should follow. One is by SEOC and the other is by ASCE, and I provided those links there. So that's a very, very serious topic, very big life safety topic. So nothing to mess with. I'll just say that.
Yeah, excellent. Well, we are right at time, so I want to thank our speakers here as well as Shannon Wilson for helping coordinate this. If we did not answer your chat in the question, please feel free to reach out with us. All of our contact information will be included in the slides that you will receive, as Shannon mentioned in the chat, in a few days. So thanks, everyone.
Thank you.